This video will continue with vertical asymptotes, holes, and get into horizontal asymptotes. If we look at this function and we look at this denominator, we're used to looking at the denominator, set that denominator equal to 0, and solve. If we solve this, we get x equals 2 as a vertical asymptote. But if we enter this function into a graphing calculator, we don't get those same curves we've been looking at. This is what we get. Notice right there that little gap. That is a hole. There is a hole right there at 2. This is x equals 1, 2. That corresponds to the fact that if we put 2 into the denominator here, we're going to get a 0 in the denominator, which we can't have. But it does not give us a vertical asymptote. And the reason it doesn't is because this numerator factors. If you think back to what we wrote in one of the early screens on the previous video, it said that the numerator and the denominator cannot have any common factors. Well, this function does have a common factor of x minus 2, x minus 2. That would have canceled out. So you need to look at your numerator also to see if it factors and cancels out with the denominator. If it does, then this number right here will give you a hole, not an asymptote. So keep that in mind. Check out the numerators. Most of the numerators in our book do not factor, and this won't be an issue, but in some other books and when you move into calculus, you will have the situation where the numerator factors and does some canceling with the denominator. So here's the rule. If the function can be factored and reduced, the value that created the 0 in the denominator gives us a hole in the graph, not an asymptote. So one comment about graphing calculators and holes. Depending on your graphing calculator, you might not be able to see that hole. You can verify that the hole is there by using the table feature on the calculator. At the point that created the hole, you will see the word error for the y value. Some graphing calculators will show the hole, just depends on your calculator. Now, let's get into horizontal asymptotes. A horizontal asymptote is exactly what it sounds like. It is a horizontal line that the curve kind of snuggles up to as it bottoms out or reaches up this way to reach its peak. The green here is the vertical asymptote as you would expect. X minus 2 would give us a vertical asymptote of 2. But the horizontal asymptote happens to be the x-axis. Now you're going to learn some rules in a couple minutes here. The reason I know it's the x-axis is because when I do the graph, I see what happens with this curve. It's coming down, getting closer and closer and closer, but not crossing the line. That's the definition of a horizontal asymptote. And the same thing happens over here. The rest of this video will show you how to actually find the horizontal asymptotes by looking at your equation. Here's the rules. You're going to want to stop the video and write these down if you haven't already gotten these in class. Horizontal asymptotes are determined by comparing the degree of the numerator and the degree of the denominator. Now, what's degree refer to? Degree is just talking about the highest power, x squared, x to the first. That's the idea of degree. So here's the three things that can happen. If the numerator degree is less than the denominator degree, then the x-axis is the horizontal asymptote. This is an example where the numerator degree, which is 0 since there is no x, is smaller than the denominator degree. That's x to the first. Therefore, the numerator degree is smaller than the denominator degree, and we would have the x-axis as our horizontal asymptote. This function right here is this example. The numerator degree is greater than the denominator degree. That's x squared, which is a degree of 2. That's a degree of 1. Therefore, there is no horizontal asymptote for that function. And the third possibility is that the numerator degree and the denominator degree are the same. And if that's the case, like in this is an x to the first, this is x to the first, so they both have a degree of 1. What you look at is the coefficients. This is 2, this is an understood 1. What you do is you look at the ratio of those coefficients, 2 over 1. That would be your horizontal asymptote, y equals 2. One important thing, the numerator and denominator must be written in descending order before you look for the horizontal asymptotes. Most of the time, in most books, they are in descending order, and you don't have to worry about that. But every now and then, it gets tricky and it's in a different order. So be sure you are looking at them in descending order before you try to name the horizontal asymptotes. Try to find the horizontal asymptote, if any, of each rational function. Look at the degrees. We have a 1 for this degree, we have a 2 for this degree. It fits this category. The numerator degree is less than the denominator degree, so the x-axis is the horizontal asymptote. The x-axis is the equation y equals 0. Remember, a horizontal line is of the form y equals some plain old number. Different one, I've got x squared. That means the degree for both of these is the same. So what we're looking at is a ratio of the coefficients. 4/2 would be my horizontal asymptote. This is this rule. If the numerator degree equals the denominator degree, then the line y equals this ratio is my horizontal asymptote. So this is y equals 2. Third possibility is that the degree in the numerator is bigger than the degree in the denominator, which says we're not going to have any horizontal asymptote. If the numerator degree is greater than the denominator degree, then there is no horizontal asymptote. So let's try to put together the three things we've talked about in these two videos. Let's see if we can name the domain and then find any vertical or horizontal asymptotes. That's about half the story of what you have to do a full rational graph. So to name the domain and the vertical asymptotes, it's the same setup. You're going to set the denominator equal to 0 and solve. So take that, set it equal to 0, and we get x equals -1. This is going to help me name the domain and the vertical asymptote. The domain is the set all x such that x does not equal -1. To name the vertical asymptote, though, we have to name it from the point of view of what is the vertical asymptote. It is the vertical line, x equals -1. Vertical lines are of the form x equals some plain old number. Horizontal asymptote, we want to look at the degree. These are both x to the first, so there's an understood 1 right here, and I'm just going to look at the ratio of those coefficients. So we're going to get a horizontal asymptote of y equals 2. Now let's take a look at the graph so we can verify that these are correct. Our vertical asymptote is x equals -1. That's my green line right here. Horizontal asymptote is y equals 2. That's my yellow line right here. This is what the graphing calculator shows as the two curves. Notice that the curve snuggles on up to the asymptotes. The asymptotes are kind of like Jell-O mold, not the mold that grows on your Jell-O, but the mold that forms the Jell-O. So this kind of conforms to where your asymptotes are. That helps lock your picture in, as you'll see as we do more graphing in a little bit. One more example of looking for the vertical and the horizontal asymptotes. The horizontal asymptote is a matter of looking at the degrees, and notice that the numerator degree is less than the denominator degree, so the horizontal asymptote is the x-axis, which is the line y equals 0. There is no vertical asymptote because if we set this equal to 0, just the denominator equal to 0, and try to solve this, we're going to get an imaginary value. So there is no vertical asymptote. This is what the graph looks like. Graphing calculator gives me this curve. The yellow is my horizontal asymptote. Notice that the curve does cross the horizontal asymptote. It is okay for a graph to cross a horizontal asymptote, but it still may not cross a vertical one. One more comment. Notice when this comes up and comes down, this does come close to the asymptote. It's kind of snuggling into the asymptote, but it did cross right there.